What's up YouTube, this is Dennis Panuta for tutorialsEU/Unity. In this video you are going to learn how to connect your button to the physics of the game without using any code. That's really the cool idea here. So you're going to learn a lot more about click events and how to connect physics to it. So if you like this video, definitely hit the like button as well as subscribe to the channel because we're uploading Unity related game development content regularly. So let's get started with the content. So let's go ahead and first of all adjust our maze, because what we want to have is basically the option to move our player through a maze that will be more or less hard for the player to get through. And you can create a maze however you want it, so you can design it the way you prefer. So what I'm going to do is I'm just going to copy my ground, I'm going to paste it in here, and I'm going to rename it to OBST. OBST is the short version of obstacle in this case. In German it means fruit, but this is not a fruit, this is an obstacle. All right, so now we can reposition this OBST, and I'm going to change the scale a little bit to maybe something like 10. Okay, so now we can play around and position the scale, let's say at 5 in my case, and you can create your very own maze here. So let me now duplicate this OBST by pressing Ctrl D or Ctrl C and V, depending on what you prefer, and then move that piece around as well. I'm going to move it somewhere around, let's say Y2, and then the X position of -1.5 will probably be a good spot. So here it will be exactly at the edge of our other element. It wouldn't be a problem even if we pushed it inside of our other item. You wouldn't see it because, well, they are in the same Z position, so to speak, but it's always good to do it in a as clean as possible manner. So here, let me select this obstacle and position it at -1.5 for the X position as well as 2 for the Y position. And now I'm going to duplicate it once again and position it a little further down, but on the right hand side, so maybe something like X 1.5, and the Y coordinate could be at -2, maybe -1. Let's try that. That will probably be a little better. And then I'm going to duplicate this obstacle once again and drag it a little further down to a point where I personally like it. Let's say here, -4 seems to be a good spot. Okay, so this will, for example, be the maze that our ball needs to go through. Now, I want the player or the ball to be at a different position also. So let me actually position it all the way up here. So maybe at Y 14.5 should be good. Okay, so now the ball will fall down, and then we can rotate our super parent as well as parent. So basically rotate our maze towards the left or right, depending on which button we pressed. Okay, so now that we have that out of the way, let's take care of our physics. And therefore, I'm going to go over to my super parent and make sure that Kinematic is turned on and constant force is turned off. This way, we are deactivating the forces. So we're deactivating the constant force as well as the rigid body itself, so it will not be influenced by gravity, as it was already not influenced by this freeze position, but it will also not be kinematic in general. So then let's do the same thing with our parent. So deactivate the constant force as well as make sure that Kinematic is turned on. And then what we also should do is make sure that we have those values set to something like 0.5 maybe for both sides. So the parent should have a constant force relative torque of 0.5. The same goes for the super parent here, where you should use maybe something like -0.5. And this is, by the way, something we can later on play around with just to see how we want to balance our game. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone and optimize it for mobile and export it for mobile as well. how to build a first-person shooter game, and finally how to build a tycoon game similar to Adventurists, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount, so don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code, as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. Okay, so now that we have our obstacles in the way, let's go ahead and take care of the actual buttons. So let's start with this left button. And you can see that there is an area here which says on click. And what I want to do is I want to do something once I click on the left button. Okay, so if we look at our game, this here is our left button. And once I click that, what I want to do is I want to tilt my maze towards the left-hand side. So how can I achieve that? Well, let's click this plus button a couple of times. And by a couple, I mean 4 times. So now we can drag an object in here and run a specific function and make a little change to it. So what I'm going to drag in there will be my super parent at the top. Okay, so let's drag the super parent all the way over here. So we get it from here and we drag it into our left button, click here. You can also select it from here, by the way. So you can click this little circle with a dot inside and you can search for super parent here that is inside of the scene. Okay, so you go here, there's assets and scene. You go to the scene and you select super parent from here. That's another option to do it. And now let's actually do something once we click on it. And what do we want to do with the super parent once we click on this left button? Well, let's go to function and here select the rigid body. And inside of rigid body, you can see that there are a bunch of options what you could change. And the thing that I want to change is going to be, in fact, is kinematic boolean. So here you see bool is kinematic. Let's click on that. And you can now see that the icon has changed. So of the super parent, it's going to now change this item. So let's look at it. It's this item here, which is the rigid body. So it's now going to change the kinematic setting of our super parent of the rigid body. Okay, so let's go back to the left button and scroll down. And what is it that we want to do here? Well, we want to make sure that the is kinematic is turned off once we click on the button. And then we also need to make sure that our super parent constant force is activated. So let's go back to our left button and make sure that here the second option where it says no function is going to activate the constant force. So you can see here are the different options that I have. Like I can make changes to the game object itself, to the transform, which means the position, the angle and so forth, to the rigid body, and to the constant force component, which is the one that we added earlier as well. So here I can select bool enabled in order to activate the constant force or deactivate the constant force. So I'm going to enable it here and I'm going to select that it should be enabled. So the value should be true, which means it will enable this item. So we are deactivating is kinematic because is kinematic made sure that our physics will not impact the item, in this case the super parent, and we are activating the constant force. All right, so now that we have selected those items, what is it that we want to enable and disable? So if we're inside of the left button, which is this one here, we want to make sure that the super parent's is kinematic value is going to be activated and the constant force is deactivated, which basically means once we press the left button, the super parent will not be executed, so the z minus 0.5 will not be running, but the one from the parent, which is plus 0.5, will be running. So it will tilt towards the left-hand side. Okay, so it will tilt counterclockwise. Okay, so let's go back to our left button, and now let's add the parent here. So you can either drag the parent from your hierarchy over here, or you can press this little circle with a dot here, go to scene and search for parent, and then select the parent. Now we need to do the same thing as we did with our super parent, but just the other way around. So here we are also going to select is kinematic, And here we're going to select the constant force bool is enabled, but here we're going to make sure that the constant force is in fact enabled and the isKinematic is disabled. So this checkbox is basically saying enabled or disabled. So here for this isKinematic, it's true or it's false. So if it's not checked, then it says that isKinematic is going to be deactivated or false. If we check it, it will be activated. So basically what we're saying here, when we click this button, we want to do all of these things. We want to make sure that the rigid body is kinematic of our super parent. Then the constant force is enabled, which is going to be set false, which means the constant force is disabled for our super parent. For the parent, however, we deactivate the isKinematic and we make the constant force enabled once we click the left button, which means that now our maze will tilt towards the left-hand side. Now what we can do is we can right-click on this button here and we can click on copy component. So here, go to button, to the button component. Here are 3 dots, then click copy component and then go over to your right button and also here and paste component values. So here in the button component as well, inside of the right button, this time not the left button, here we are adding them because you see here are no on clicks. Of course you can add them manually if you want, but we can also just paste our values, the component values, and now just do the other way around, which means here we are going to deactivate the kinematic for our super parent once we click on the right button, and we are activating the constant force. We are making our parent kinematic and disabling the parent's constant force. As you might recall, super parent was what we used in order to rotate towards the right, and the parent what we used to rotate towards the left. Okay, so at this point, let's actually run the game and see if we can tilt our game around. So let's move towards the left, and you can see it starts moving. So it tilts towards the left. And then once we don't want it to move towards the left, we click this other button and you see it will rotate towards the other side. Okay, now let's also play around with the values a little bit because you saw it tilted quite heavily. So let's change that. And that was because when we tilted towards the right, it was too heavily tilting. So let's change the value to maybe 1/10. Let's try how that's gonna look like. And let's run it. So now, once the game is running, press the left button and then it starts tilting. And then once it's at the spot where you're happy, go ahead and tilt towards the other side. It starts tilting. And then once you're happy and you want to tilt back to the other side, we're tilting again. And there we are. So step by step, everything is tilting. Now you could, of course, play around with those values of the constant force for both of your parents. So for the super parent as well as the parent. And then the goal is to get to the bottom, even though we haven't implemented the functionality for that yet. We're going to do that later on. Now you could say, okay, maybe it would be a good idea to also add a break button so that it doesn't tilt at all. So that's something you could add as a little challenge for yourself. You know now how to add buttons, and you also know how to change the rigid body as well as constant force when doing so. And then there's one little thing that I also noticed, and that is that in the parent I changed the angular drag to 0, but in the super parent I didn't do it. So that is also something that is still impacting our game. So let's make sure that we have an angular drag, so basically a reduction of the rotation speed, so to speak, for the physics of our super parent. And then let's run it again. And now it should be a little better when it comes to moving. And there is something else where you might wonder, why am I using a relative torque of 0.05 here instead of 0.5 as I do with my parents? Well, that's basically just really testing. So you can play around with those values and see what feels better. So here you can see, like, if I do that towards the right, it's still moving a lot faster than towards the left. And that has to do with my parent being inside of the super parent and therefore having all the physics in there, like all the walls and everything, and this makes it a little slower. So that's why I'm using a different value here, because otherwise, like the super parent would be way too fast. We're using 0.5 as the relative torque, which is basically a relative force towards rotating. So torque is just a force that is a rotational force here. All right, that's it for this video.
Thanks a lot for watching this video. I hope you enjoyed it. Now you're one step closer to becoming a Unity game developer. And if you haven't liked the video yet, please do so now, as well as subscribe. And also make sure to follow along in the playlist to become a real Unity developer. And if you want to fast track the whole development process of becoming a developer, then definitely check out our Unity Masterclass, in which you're going to build a bunch of games, and while doing so, learn everything you need to know about game development and, well, have your first couple of projects under your belt. So check it out. The link is in the description below. You will get a huge discount, and I hope to see you in the next video.